Hi there, everybody. Welcome to another Teach Kelvin Your Thing session. I'm pretty excited about this session because it's one I've been waiting to have for quite a while now. And I'm going to have it with someone I really admire a lot because of his work with one of my favorite tools. So please welcome Praneet. Hi there, Praneet.
Hello, everyone. So, Kelvin, thank you for hosting me here. I really appreciate it.
Yes, please thank you for joining. I know you could be super busy because you're working on one of the most important apps in the world, in my perspective. So I'm really happy to have you. So, could you take a moment to introduce yourself, like who you are, the app I've been rambling about, and what you do generally?
I'm Praneet Rohida. I'm from India. I've been building Sizzy. That's the app Kelvin has been talking about. So, Sizzy is basically a browser for developers. It's a tool which, lets you test and develop your websites with a much higher efficiency than your regular browsers like Chrome, etc. And about me, I'm a front end developer. I work with stuff like React, Electron, Chakra UI, and all of the good things.
Awesome, awesome. So
Yeah.
yeah, there you have it, folks. Sizzy. If you don't know what Sizzy is, or you haven't used Sizzy and you're in web development, please do yourself a whole lot of good and go grab a license, please. You're going to enjoy the workflow. I also have like a series called Quick CZ Tip. I love it so much. I do a series on a tip every week. So go check that out. So thank you again. Okay, so what are we learning today?
Yeah, so we are going to learn Electron today. We see, all these desktop apps getting popular that are built with Electron. And for example, for people who might not know, Visual Studio, Twitch, Slack, Spotify, all of these apps are built with Electron. So Electron is basically a framework which lets you build, desktop apps using your regular web technologies, so you don't have to learn uh, anything, something completely new. You can use your existing web technologies, HTML, CSS, JavaScript, and all of that, and build awesome desktop applications. So that's what we are going to learn today.
Awesome. So, my first impression about Electron
Mhm.
was I think I tried using something like Native Script with Vue and also React Native a while ago. I was trying to build like a mobile app, and the idea of using web technology to build native applications was very, very interesting to me because, of course, one language and you have it everywhere. But
Yeah.
the experience wasn't really that great. I think this was maybe 2019. It wasn't
Mhm.
really cool. So when I heard about Electron, I was like, oh, this is going to be not good as well because of the developer experience. Like it was good on paper, like documentation, everything was working as they say, but when I was using it, I had to go back learn Swift so that I
Mhm.
could write because it was really better tooling then. But I found out that Electron was easier in my perspective. It was really, really simple. But I'm not an expert in it. I think you should be because Sizzy, the app we were talking about, is an Electron app, right?
Yeah, it's an Electron app.
Yeah. And in terms of quality, performance, and speed, I think Sizzy really, really shine and check all the boxes on that. So I think I'm gonna let you lead and just take us in this journey on building desktop apps with Electron. All right?
Yeah, sure. So yeah, as you said, Calvin, like with React Native and stuff, the difference is that even though like they are mobile application building tools, but they introduce, a whole new layer of abstraction. So for example, the UI layer in React Native is not similar to that of web. You cannot, just put HTML tags in React Native. So that's an additional learning curve, and I think what that was something that put you off when you tried to use those technologies. But with Electron, it's completely web. So when you run Electron, you are basically running Chrome inside a container. So every time you imagine an Electron app, imagine a Chrome tab with some extra stuff on top of it. So that's how Electron works. So yeah, let's start by looking at the architecture of Electron, I guess, like
Mm-hmm.
how it works under the hood, what it
Yeah,
packs, and then we'll move on to some coding.
nice. Should I share your screen now?
Yeah, you can share my screen.
Okay. Awesome.
Yeah. So, do you like robots, Kelvin?
Yeah, I do. I fancy them.
Yeah. Okay. So, let's meet a robot then. So here's a robot called Electrobot.
Oh.
It's basically an architecture diagram of Electron I created,
Mm-hmm.
but it looks like a robot. So I called it
Yeah,
Electrobot.
looks like
Yeah, these are the
Wall-E.
eyes, it's a body, these are the hands, and these are the most important part, the wheels.
Nice.
Okay, so let's try to understand how Electron works basically. So, uh, Electron has a multi-process architecture. So, like even Chrome uses multi-process architecture. So, whenever you open a new tab in Chrome, it starts a new process on the OS. So every Chrome tab is a different process. Electron is a similar thing. So you have a bunch of renderer processes. Consider each renderer process like a Chrome tab, or uh, a process that handles rendering of your like code, your HTML, JavaScript, and stuff. And we need a process to control all of these render processes. So for that we have the main process here. So this main process, this is actually the entry point of your application. So whenever you start an Electron application, it will the code that you write in the main process, it will run first, and then it will start a bunch of render processes, or one, like however you define it. It will start a render process, and your render process will actually display your the UI of your application. So like let's see how these processes works. So the main process is a node process actually. Uh, so Electron basically is, you can imagine Electron as node and Chrome bundled together.
Mm-hmm.
So you have access to both the node runtime and Chromium itself. So you can load all the web stuff in Chromium. So the main process has access to all the node APIs. So whatever you can do in node, access the file system, the sockets, and all of that stuff, everything you can do in node. And in addition to that, there are some Electron APIs, a bunch of APIs provided by Electron, which help you uh, access and do additional stuff that you usually would want to do in a desktop application. For example, save a file or show some desktop notifications and stuff like that. So this is what the main process can do, and the render processes are have access to all the web APIs. So whatever code you can run inside a browser, uh, all of that can be handled with a render process. A render process can run all of that, and in addition to that, the render process can also have like access to the node APIs, but you need to enable that. They don't have it by default, and there's a reason for that. The reason is security,
Mm-hmm.
and we'll get onto the security later. So uh, for getting started, you can you know uh, assume it like this. The main process is created first, and it handles all the native stuff, all the stuff that is responsible, all the stuff that is related to the OS and the application, and all the UI stuff can be handled by the render process. So
Nice.
that's how uh, this robot actually works.
I like it. I like it.
Yeah.
So yes. So from what you've explained, I could
Hmm.
see Electron as both Node and Chrome. Not really Chrome the
Yeah.
browser, but Chromium the engine, right? Which is like
Yeah.
the
Right.
renderer. So Node gives this, should I say, this access to file system and everything we have in Node, of course, while
Yeah.
the renderer, which is the renderer process, helps us like with the
Hmm.
UI and everything. Am I right?
Yeah. Yeah. Right.
Awesome. That makes sense. I like it. So I could see an arrow there, window management app lifecycle. What is that?
Yeah, so that's another responsibility of the main process. Window management is, creating and handling windows. So whenever, for example, any application opens a main window, and then you do some things and it might open another window. So all
Oh,
of this, uh, every window that opens will create a renderer process, and managing all of them is done by the main process. And there are parts of the app lifecycle, like whenever the app is opened for the first time, uh, whenever the app is quit, whenever someone focuses in the app, whatever stuff you want to do with these events, that all come under lifecycle, and that is also handled by the main process.
nice. I don't think I've used the app lifecycle before because even in my little app,
Hmm.
Guppy, I think I just have one window, of course. So,
Hmm.
and I haven't really like. I think okay. I don't know about there are some events that Electron would emit, right?
Yeah.
Yeah, so but
Yeah.
aside from that, I don't think I know the app lifecycle in depth, and this is really an eye opener.
Yeah, like there are a bunch of things you can do with the app lifecycle events. Uh, for example, let's say your app does some, background processing. Maybe
Mm-hmm.
you are checking something with the server, or maybe you are processing something, but you don't want to. You don't want it to affect the performance of the user system. So, what you can do is that you can have a uh, like using the app lifecycle events, you can detect whenever the user has focused away from your app and whenever the user focuses back. So uh, whenever the
Nice,
user focuses away, you can maybe stop the background processing just to save the system resources, because they aren't really using the app right now. And whenever the user comes back to your app, you can resume that. So that's one way to use the app lifecycle events. You can do a ton of things, like there's a
oh,
ton of things you can do.
nice, nice. This is cool.
Yeah.
I like it.
Yeah.
Mhm.
All right. So let's start with running an Hello World app.
Mm-hmm.
Yeah.
Let's do
Okay.
it.
So it is much easier than you might think. We don't even need to write a single line of code. Like,
Really,
we can just run an Electron app without writing any code. So
magic.
there's a thing called Electron Fiddle.
Mm-hmm.
It's a desktop application. So you just download it, and I'll show you what it is. So let's run Fiddle. Okay. As soon as you open Electron Fiddle, you'll get a bunch of code. And this is your Hello World app. You can just press run, and here you go. You have an Electron app running.
Wow.
So this is just like basically, you can say a code sandbox, a mini version of code sandbox, but for Electron. So whenever you want to quickly do something in Electron, try something out, you can just, instead of creating an application with npm, adding dependencies and stuff, you can just fire up Electron Fiddle and do it here.
Hmm.
And you can also publish it and stuff. So yeah, let's look at the code now, how it works, how it actually works. So uh, these are the files that we have to get started here in the editor.
Mm-hmm.
So this is the main.js file. This is a, this is the main process that we were talking about. So the main process will run this code, the the main.js file, and this is the renderer process code. So this is normal HTML that you would use on the web. You can see that this is requiring a script called renderer.js. Nothing fancy here. You can this works the same way like it does on the web. And render process is this file, the renderer.js file. It does not have any code right now. We'll get to why. And there's another file called preload.js, and this has a bunch of code. So this is also normal javascript. So you can see there's a dom content loaded listener here, a normal web listener. It gets a selector and sets some text for it. So you can see that what this process is doing, it's accessing process.versions, and it's for these keys, it's getting the value from this object process.versions, and it's setting it on a certain dom element. And you can see if we run the app again, let's go, yeah, let's try to run it again. Okay, you can see that it's displaying the versions. Your app is running Node 16, Chromium 100, and Electron 18.2.3. And there's the CSS file, which is just a regular CSS file. You can do stuff like body color, um, and if we run this again, you'll see that your body has brown color, just like it works just like it does on the web. So let's see what is this preload.js file, and why doesn't render process have any code right now. Before that, let's look at the render process code first. Main process code, what is it doing? So here's a function called create window. Like it's pretty self-explanatory. It's creating a window. There's an constructor called browser window, which you're getting from Electron. So you are initializing a browser window. You pass in some things like width and height, and you pass a parameter called preload, and you send the path for the preload.js file that we have here. So what preload does here is that there's a bunch of it's a code that will run before loading your actual page. So like whenever you load something in electron in an electron window, it's just like loading something in a Chrome tab. So before loading the web page, it will run whatever is inside the preload.js file. Okay, so we pass the path to that file here, and then we load the our main index.html in the main window. So we call main window.load file index.html. uh, you can also load urls, so we can try one thing, main window.load url, and can load, let's say, google.com. And now if we run our app again, you'll see our app is running Google inside it. So yeah, basically you can load anything. This is just like a regular uh, browser tab. You can load any file or url here. So this is what the create window function is doing. And after that, we have like uh, app. What is app now? It's also coming from Electron. As you see, we require app from Electron. So this is basically a bunch of this provides a bunch of APIs that are concerned with your app. So we'll see what else it does. We'll look at the documentation soon. But for now, we want to uh, look. What we want to do is that whenever the app is ready to run, then we want to create a window. So uh, yeah, here we have, whenever the app is ready, we create a window. We So when ready is a life cycle helper. So we talked about life cycle methods. So ready is one of the event that electron fires. So whenever it returns a promise. So if you are familiar with promises, then whenever this promise resolves, this code will run. So whenever the app is ready, or if you want to, if you are more familiar with event based APIs, so you
Mhm.
can also do app dot on ready, and then you can do anything you want. This will work the same way as this code.
Nice.
Yeah.
Got you.
Uh, So, this what this line is doing here is that, uh, like, this is specifically for Mac OS. You don't need to have this, and you can safely ignore this. But because it's here, I'll explain what it is doing. So, uh, for folks that have used Mac OS, you might have noticed that for any Mac app, you can just close the window, but the app might still be running without any windows. You'll see the icon in the dock, and uh, but there are no windows for the app. So this is to handle that case. Whenever there are no windows and someone clicks the app icon, then it should create a window. uh, During
Oh.
that, uh, in that flow, the ready won't be fired because the app was already ready, like it was already running before the user closed a window,
Mm-hmm.
and now we want to detect that. So an activate event is fired in that case. So app.on activate, we can check if there are no windows, that we can create a window. So browser window has this method called get all windows, which will provide you all the instances of browser windows. For example, this was one instance that we created in create window. So all the instances that you have in your app of a windows, you will get them here, and if there are no instances, then we create a window. And yeah, so uh, that's how starting the app works. And let's see what we have down here. So this code is specifically for OSs other than Mac OS, like the behavior that we discussed right now. When we close the window, the app still remains open, but it doesn't work the same way on Windows or Linux. And on those platforms, when you close the last window of an app, the app is quit. So to handle that case, we have another lifecycle event here, so which is called window all closed. So whenever all windows are closed, there are no more windows remaining of the app. And if the platform is not Darwin basically stands for Mac OS. So if the platform is not a Mac OS, we call app.quit, which will basically quit the app, which will make sure this render this main process has stopped working, and it will call all the other lifecycle methods. For example, you can also have something on quit, app.on quit. You could do a few things here. So all of those lifecycle methods will be called, and the app will be safely closed. So yeah, this is what the main process does. So now let's look at the render process. Now here we saw that we can also load URLs, right? We could directly load uh, google.com or any page on the web inside your application. Now, you might already see that this can be a security threat. For
Mm.
example, uh, let's say my app ends up loading some other external website, and that website is running inside Electron now. So it might have access to, you know, uh, the Node.js APIs. Like it might get access to file system and stuff, which we do not want, obviously, because we might not trust that code. So that's why we have preload.js file. So like basically the way it works is that uh, by default, as we said, the Node APIs are not available inside the render processes.
Okay.
So, and being a desktop app, you might want to access the Node APIs. You might want to do certain things with the file system, show something in menu bar, or stuff like that. So, for that purpose, like you need to obviously write some code in the render process that has access to uh, Node APIs. So what you can do is that like uh, you can see the uh, this file by default does not have access to the Node APIs, so you cannot use Node APIs, but we can enable it. So there's a function called node integration. There's a option called node integration. If we enable it, this process will have access to node APIs. So the way you access the node APIs in render process is that you call window.require. So in a normal node process, you would call require fs, but here you would call window.require. That's how you access the native APIs in Electron in the render process,
Oh,
and you
really?
can use this. But yeah, so you can do fs.read file and you can do certain things with this file, but obviously like you might not be in control of this render process. For example, if it's some other page on the web, you uh, cannot control that code, let's say. So in that case you would use a preload file. Preload file will be run before uh, loading this actual render process. So before loading your HTML file, it will run preload.js. You can do a bunch of stuff here, and by default, it is these the context for these two are separate. So it is not possible to even by mistake to create an security threat here. So let's say if I do window.fs equals to uh, require window.require, as we said, fs. Now what I did here was that I assigned the fs module on a variable on the window object, the regular window object in the DOM, to fs. Now whatever the code the render process is running, it might get full access to the user's file system, which is not ideal, which can be a security threat, right?
Mm-hmm.
So that's why there's an option called context isolation, which is true by default. So what context isolation does is that it separates the context of these two uh, files. So whatever you do here, if you assign window dot f like window.fs here, here it will be undefined. So window.fs will come out to be undefined here. So that way it is not possible to expose this. uh, but yeah, if you trust the code that you are running in renderer.js, then you can obviously go ahead and do context isolation false, and you can directly use the APIs that you want. But if you are loading some external URL, for example, then the safer way would be to do it via preload.js. And there is another way to send stuff from here to here, that's called context bridge. But for this session we are not going to worry about that. We are not writing some fancy enterprise high security application. We are just some guys learning it. So let's not worry about that fancy stuff here. Okay,
Yeah.
cool. So yeah, this is Electron Fiddle, but obviously this is just to play around in Electron. If you actually want to write some applications, you would do it in your actual IDE and not the Electron Fiddle. So yeah, let's do that. Let's see how you can build an actual desktop application.
Yeah. Cool. Thanks. I
Yeah.
think I did not know about the window
Hmm.
dot require before.
Yeah.
I've
Hmm.
used the preload and I think a little bit of the context bridge. But again, I am no expert and I think I'm learning a lot of the actual context of all these files and why we use them.
Hmm.
Yeah.
Yeah, that's great. I'm glad you're learning something. Like, I'm glad I'm being able to help. So
Sure.
yeah. Uh, let's start with creating a regular React application. You don't need to use React. You can use anything you like. You can use Vue, you can use jQuery, you can use Svelte. But yeah, for this example, let's start with React. Uh, let's create a React application for TKYT. And we'll see how we can convert this plain regular React application into a desktop app and do fancy stuff with it.
All right.
Yeah, and we are almost done, I think.
Okay.
All right, so let's open it in Redstone. Here we go. Here's our code. Let's move this one here. Okay, so this is just a regular React application. You can, let's close this bunch of pop-ups. You can just uh, run it and it opens in the browser.
Mm-hmm.
Now let's turn this into an Electron app, right?
Yeah.
So yeah, let's actually add Electron as one of our dependencies here. This is the latest version. We run yarn install. Meanwhile, let's also create an env file here for create React app uh, to say this is basically a create React app thing. When you add this to the env, it does not automatically open it in your browser. So that's what we want because it's not a regular web app anymore. This will be a desktop app. We don't want to open it in Chrome. So yeah, our Electron is installed. Now let's create a file for the main process. Okay. Uh, electron slash main.js. This will be our main file, and uh, we said that main process is the entry of the app, right?
Mm-hmm.
So we define it as slash main.js. So just so Electron knows where to find the code for the main process. So this is the entry point of our application. Here we go. And uh, let's import browser window and Electron from Electron. And now app dot when ready. As we remember. Okay, so GitHub Copilot actually automatically did this for us.
Oh,
But yeah, let's. Do you use GitHub Copilot, by the way?
nope. I haven't
It's
jumped on that
amazing.
train.
It's
Really?
amazing. You should. Yeah, it
Hmm.
automatically writes code for you. Like I didn't even write this, but yeah, let's ignore it and let's write it ourselves.
Okay.
Yeah, let's actually create a function, for this as we saw in the hello world app. So this will create a new browser window. Let's give it 1,600, and let's not worry about this web preferences and node integration for now. Uh, let's just create the window and load window dot window dot load. We'll do load URL because right now we are running it on a URL. So create React app loads on localhost 3000. So let's load that inside our window that we just created. And when the app is ready, just create a window. And now let's add a script here. Start name is to Electron dot, and let's call this start renderer. Okay, so now we'll start the render process, which is just a create React app thing. Let's close this one. Okay, unexpected token. Okay, sorry for this. Yeah, so render process has started. Now, if we start the main process, ideally we should see a window which is running our Electron app. Amazing, right?
Yeah, it
Which is
is.
running our React app. So a regular React app is now a desktop application. So let's do some fancy stuff with it. Let's find our app.js file, and yeah, uh, let's declare a variable called name here. Let's keep it empty for now, and let's say something like name to not React to Electron. Okay. So this logo. Okay. So right now we don't have a name, and we want to do it the fancy way. So let's do one thing. Const os equals to window dot require os. This is how you access stuff from the this thing, right? Stuff
Mm-hmm.
from native the Node APIs, right? But now we see that our app has gone blank. Let's open the dev tools and see what has happened. Window.require is not a function. Sorry
Okay.
for that. So,
So,
uh, yeah, what's happening here is that, as we said, the render process by default does not have access to the Node APIs. So, let's go to our main file here. Let's give it the access for the sake of this example. Let's not worry about security. No one is going to hack our Hello World app. So
mm-hmm.
let's uh, do node integration true and context isolation false. We already saw what these options mean, and
Yeah.
now let's restart the main process. Like whenever you uh, make changes to the main process code, you have to restart it so it can create the window again and the app runs again. Like it does not have hot reload like normal React applications. So that's something you have to keep in mind. And yeah, our app is running again. Now let's go back to our app.js file. Okay, now let's move it up here and let's get the uh, name from the actual system. You can see I typed this and it automatically got my name.
Nice.
So you can directly access the native APIs. So Node.js has this OS API that gives you the user info, and a regular React application could directly, use it to do stuff. Yeah. So yeah, you can see it's pretty easy once you like most of the stuff is common to Node.js and like the web technologies. So if you are already familiar with HTML, JavaScript, and some Node, then you are good to go with Electron. So, uh, like, do you have any questions up until now?
No, I I really don't have any because like I said, I'm really learning a lot, especially the so I know about the node integration through, like setting it to
Mm-hmm.
true in your web preferences object because I use it in
Yeah.
guppy. That's the way we allow you to like run because what guppy is, it lets you run JavaScript code and you get to see the output. Just to give you a nice DX in terms of
Mhm.
debugging JavaScript sales application. So I have to set that to true so you could run your code. So
Yeah.
even while I was doing that, I was using the preload file to send things like API I need in the UI
Mm-hmm.
through that
Uh-huh.
file. I didn't know I have access to dot require in the window
Yeah.
object. Yeah.
Yeah. So if the I mean, it's fine to send it via preload file.
Yeah.
It's even the recommended way.
Mhm.
But like in some case, if you directly need to access something, you can do that as long as you trust the code that you're running in the render process.
Got it. Got it. This is cool.
Yeah. Yeah. And yeah, so that's about how we can you how we how we can run the main and render processes.
Yeah.
Now, what if these two processes want to, you know, talk to each other? So uh, let's do something like that. Okay. So let's say I want to, you know, I don't want to access the API call here. I want to do something from the main process. So to talk between the two processes, we'll use something called IPC.
Okay.
So we have IPC, since we are in the main process here, we'll use IPC main, we'll require it from Electron. And IPC is basically a communication channel. So the main process and render process can talk through it. So it's basic like channel based communication. So whenever we can define a channel called IPC main dot let's say handle, we'll call it get name, and we'll return, let's require OS here. Return user info dot username like we did here, and let's have another handler here, IPC main dot handle. Mm, let's call it quit app. This will do app dot quit. Okay. So IPC main dot handle. What this does is that it tells Electron that whenever someone tells you to get name, you handle this by running this function. So whenever some render process sends something on this communication channel, this function will be the one handling that. And now let's go back to our render process, and here now we don't want to get the name from this anymore. We want to do it from the IPC. So let's do it here. And uh, yeah, you should actually be using use effect and stuff for this, like going with the React conventions. But to keep this simple, uh, so that even folks who don't use the React understand what I'm doing, I will be doing it the dirty way. Okay, so let's get IPC here. Const uh, yeah, IPC The way you actually do it here is, yeah, I think you can directly require it from Electron. So let's get IPC renderer equals to require. We cannot do require, we need to do window.require here. So IPC renderer, we get it from Electron. And now, uh, yeah, let's actually create a function here. Mm, or no, let's do it the dirty way, as we said. IPC renderer dot invoke. So now we invoke a function from the main process, which we called get name, and uh, like this will be a promise. This will happen asynchronously. Here we'll get a name, and what we can do here is we can say name equals to name. We obviously need to convert this into a let, so we can change it. Uh, okay, this is empty because we made changes to the main file and those haven't been registered, like we did not restart the main process yet. So yeah, okay. Let's see what happened here. We are getting it empty still. So yeah, let's debug this. Okay, so we have IPC main dot handle. Let's see if this is getting called. So what we'll do is we'll log here. It was called, and we'll run the process again. Yeah, you can see get name was called, like actually ran. So it returned the username. Let's see if the render process received it. We'll go back to our render process. We did IPC render.invoke get name, and then let's see if we actually got the name here. Let's open the dev tools here. Yeah, we got the name. Okay, so I know what's happening. This is, we are using React. So this should be a state variable actually.
Okay.
Okay, yeah, import that. Use state. Yeah, all right. Now we do set name, name. It should work. Okay. So now instead of accessing the name directly, we ask the main process like, what is the name? And the main process told us the name is Praneet. And now let's use the other function here. Let's, uh, yeah, let's create a function here. IPC render.invoke quit app. Did we call it that in the main process? Yeah, we called it quit app. So yeah, and we add an on click on the button. What happens when we click on buy? Our app is gone. So that's how you can interact between main process and the render process. Like in this case, it might seem very trivial. Like
Mhm.
uh, you might be thinking, why would you want to do this? For example, you could have directly, you know, got the name from here itself, like we were doing before. Why do we actually need to get it from the main process? So sometimes there might be cases where you might want to do much complicated stuff. You might be working with multiple windows and stuff. You might uh, want to get something from another window, or like the main process is doing the work of handling many windows, so it has some additional state there that you might want to access. So in that cases this is very useful. In that cases you would actually want to talk to the main process instead of directly trying to do it from here. So that is one of the use cases for this. And another thing is that like whatever electron uh, whatever electron apis we use, like the node apis are directly accessible from the main process if we enable node integration, but the electron apis are not, and that is for a performance reason. So the app has a number of things here. For example, this app.whenready, and let's see what else the app has. So yeah, it has these bunch of apis that you can use. uh, let's find a simple one here. Yeah, there's app.hide. This will just hide the app. It will not quit it. It will hide all your windows. So uh, stuff like this that you require from Electron, this is not actually accessible in the um, in the renderer process. So for that you would want to talk to the main process. There is a way to do that. It's called Electron Remote. So it used to be built in. This used to be a built-in module, but they moved it to a separate npm package recently, and there was a reason for that. You can see this warning here. So, uh, like if you enable this remote module, you can directly require window.require electron.remote, and I mean, yeah, this was the old way. So you can do electron/remote, and then you can access all the electron apis. So you can create a browser window from another browser window, so you don't have to talk to the main process for this. One render process can spawn another render process, and you can, so this improves the dx a lot, but it is not the recommended way. Like even in Sizzy we ran into this. We had to refactor the whole app because we were using this way, and we were running into performance issues. But if you're building a small application, then it doesn't make much difference. Like a few function calls that take a few milliseconds extra won't make a huge difference for you. So it's up to you. It depends on your application. If you are fine with these pitfalls, you can improve your dx much more. You won't have to do this ipc render.invoke for everything. You can directly use the apis from the main process in the render process by enabling this remote module.
Nice.
Yeah.
So I think from what you've explained, you want to
Hmm.
keep most of your business logic in the main process, while your
Yeah.
UI logic, like all the logic for just anything has to do with your UI, should be
Mhm.
on the renderer process. And if you have to communicate between them, you could use the IPC main and IPC renderer. Makes sense.
That makes sense. That's the way to do it.
That is good.
Yeah. So was there any problems that you ran into while developing guppy? Maybe we can discuss those. We can see how we can do more stuff with Electron.
Yeah, sure. So, okay, like the first thing I had issue
Mm-hmm.
with for some reason my setup with Webpack, because with copy I need to like require your like a local folder,
Mm-hmm.
right? And
Yeah.
load it up so you could play with your models and your functions in that file. So with the Webpack setup,
Mm-hmm.
for some reason, maybe I didn't know enough of Webpack. I wasn't able to require the local module. So I had this big error that the whole app crashed. But I switched to using Vite for the build process, and it didn't have the
Mm-hmm.
whole require issue. So have you run
Uh-huh.
into something like that with Webpack where you can't really require like a local file or a module?
Yeah, I think what might be happening is that uh, you might be running some part that should have been run in the main process.
Hmm.
So, for example, like I'm assuming the Webpack was used to build the render process, right? The React or Vue or whatever app
Yeah.
you were
Yes, the view.
building. Yeah, yeah.
Hmm.
So you might be requiring that the local file directly, and since bundled apps are packaged into a single javascript file, a javascript bundle that has to be loaded in the browser. So like this requiring a local file might not work in that case, and what white must be doing is that it might be copying the file and bundling a copy of it
Yeah.
along with your this thing. So uh, I think one way to do it would be to move that file that you're requiring to the main process and let it handle that, because main process can require fs and stuff. So was
Okay.
that a file from was it a file that the user selected, or was it a predefined file inside
Yeah.
a code
So
base?
it's a file the user could select.
Haha.
So yes. So I think I get you. So back then, while I
Yeah.
was writing this app, I didn't have
Uh-huh.
much experience with Webpack like I do today because I'm actually working on another
Mm-hmm.
project that requires me to read the
Mm-hmm.
whole Webpack documentation, so I really know how it works. So I guess when I was using the require, because how Webpack was, I think it exposes its own require, so it's not node
Yeah.
require function.
Yeah.
So since I was
Yeah.
doing
Exactly.
that, it was thinking, okay, I'm going to bundle this up with every other asset, but I don't want this particular one to be bundled up.
Mhm.
So the easiest thing to do then was to use Vite, which is like an alternative to Webpack. And since I was in a Vue project, it was just
Yeah.
so easy to make that switch. So
Mhm.
it's worked well for me. So maybe I might see a need to revisit that, but for now, everything is good. And Vite was even kind of faster than Webpack. So
Yeah, that's
yeah,
great.
yeah.
Yeah. So I believe the right way would be to handle it in the main process, since you said it's a user selected file.
Mm-hmm.
This will be actually handled during runtime, right? Not during compile time.
Yes, one time.
Uh, yeah, after the app is built and packaged, the user runs the app and then the user selects the file, right?
Yeah,
This was the flow.
yeah. So
Yeah.
I
So Webpack. Mhm,
okay.
yeah.
Yeah, so what I was doing was that when the user clicked the button, because if you visit copy.salescast.com, there's like a demo of how it works. So when the user clicked that button, I send a message to the main process,
Mm-hmm.
which opens up the file dialog, right? So you select
Yeah.
the folder, and I
Yeah.
send the folder the directory structure
Mm-hmm.
back to the UI.
Render. Yeah.
Yes, yes, render process. So the thing is, why I send that as a string, in the render process and the preload file, I have to run some logic to start up that application and stuff. So I think I'm not even hitting the UI yet. But for some
Mhm.
reason, even though I'm in the main process, after loading up the folder and starting up the app, it just didn't
Mhm.
work. So there was conflict with Webpack require function. And like I didn't really know
Mhm.
what that was because this is like a while ago. But the gist was that I wasn't using Node require at a point, which doesn't make sense
Yeah.
because I was in the main process, so I
Yeah.
should be in Node. So I don't know. Maybe during the process of sending those messages,
Mhm.
something just get
Mhm.
jumbled up along the way.
Yeah. Yeah.
Mm.
Or maybe what you could do
Mm-hmm.
is that you could shift that whole logic to the main process itself. So whatever you were doing, processing the directory structure and
Mm-hmm.
starting that application, you could do it in the main process and then send the final results to the render process to
Mm.
display the UI.
Yeah,
Because that way you will have access to all the node requires and all the node stuff there.
and that's true. Like I think it is up for a major refraction, because I do know I was exposing some code that I would call in the UI.
Mhm.
So I guess that call, which is also going to call the require, that's the issue there.
Yeah,
So yeah, thanks. I'm definitely going to definitely fix that. So
yeah.
one other thing that is a coin pin for me, because um which is updating, right? So
Mhm.
the way I'm updating currently is that I think I'm using AWS S3 to do
Uh-huh.
that. So how do you handle? Because right now I'm doing something which is not cool. I have my some credentials in the code, which is okay
Mhm.
because the code base is private, but I would prefer not to. But on the web and on Node, we can use .env and stuff to set that up.
Yeah.
But yeah, so but these those keys need to be used when the app loads in user line, so we get to check the bucket. If there's a new update, then ask the user to download. So is there a way to like put that in .env sort of, so that I don't have to hard code it in the code base?
Yeah, you can definitely put it in ENV. So, since it's related to updates, you might be using it with the main process, right?
Yeah. Yes, it's on the main process.
Yeah. So, are you bundling the main process right now, or are you just like are you um packaging it directly? Are you using Webpack on the main process right now?
No, I'm using Vite. I
Mm-hmm.
think Vite is also touching the main process, of course, because that's how it starts up the entry point. Yes. So Vite also
Mm-hmm.
touches the
Yeah.
main process.
Yeah. So what you can do is either, since I've not used Wheat, I don't know how Wheat uses environment variables, but
Hmm.
the default way should work. Like however you load environment variables using Wheat, and there's this package called .env. I don't know if you've
Yeah.
used that.
Yeah, I am
So this
familiar.
is a module that loads your files from your local .env and stores it in process.env. So yeah, here's the S3 example that you needed. So uh, you can on your local system, you can create a file called .env .local or just .env and add the credentials there, and add this file to get ignored, so it's not pushed to the repo. So whenever you load require.env.config, you just uh, get all these variables inside your code. Uh, so yeah, that's one way of doing it. And when you are running the app on the CI, for example, are you
Hmm.
doing local builds or are you building on the CI right now?
Right now, I'm building locally.
Yeah, so locally this should be fine because your environment variables will stay in your .env file, which is uh, in getignore, so it won't get pushed to your repo actually.
Hmm.
This will just get bundled in your file, and uh, like if you're building on the CI, you can use, like, the CI provides you ways of adding secret environment variables. So GitHub Actions allows you to add secret variables even as your pipelines. So using that, you can keep this variable secret on the CI without having to push these values inside your code.
Okay, cool. I like that.
Yeah.
So, okay, so the next questions I have is
Hmm.
mostly about debugging. So right now, the current, so I was working on some changes to Guppy.
Hmm.
So I tried building it. So I want like a universal build, right? And
Yeah.
then the Linux build, Windows, and the rest. So currently, after I did some updates, I have a blank screen. Not really like a white screen though. So I could see the color of Guppy. So definitely the renderer is loading up a bit, but I can't see any other thing on the app. So you mentioned I could turn on dev tool in production, something like that. How exactly would you do
Yeah.
that?
Yeah. So what you do here is that I think it's an option on preferences. you do DevTools true. By default, it's enabled only in development. You don't get this in production. So whenever you do this and you run the app, even in production, you can press the DevTool shortcuts. I think Command Option I, and it will open up the DevTools for the
Oh,
render process.
awesome. Awesome. Thank you.
Yeah. So just like we did in development right now,
Mhm.
yeah, we pressed Command Shift I and it opened up the DevTools. So this will work in production too. uh, if you enable the DevTools option from here, and that way you can debug it. Most likely, like since you upgraded Electron, I
Mhm.
think some API might be deprecated or something,
Mhm.
uh, or the bundle might not be loading in the uh, production build at all. So you'll see whatever it is here, like uh, just like
Yeah.
we saw window.require is not a function. You'll see like whether the file actually loaded or not,
Awesome.
and you can debug that way. Yeah,
Thank you. Definitely going to try that out. Thank you a lot.
yeah,
So
yeah.
I think final question because we're at time. So
Yep.
I think after building your app, your awesome application, distribution is kind of like
Mm-hmm.
the main thing. And if
Yeah,
it's an, I think if it's an open source app, it's kind of easy because anybody could just download the app from GitHub. But if it's like a
yeah.
commercial application like Sizzy and like Guppy, what I don't need you to tell me the entire details of how Sizzy
Mm-hmm.
distribution works, but how would you
Yeah.
distribute a commercial Electron app? Yeah,
Yeah. So let's go with what you're already doing. You are using Amazon S3, right? So uh, there's something called Electron Builder. I'm sure you are using this.
yeah.
Yeah. So you can see the publish options available here.
Mm-hmm.
So uh, it allows you to publish it to either GitHub. If you publish it to GitHub, it will create a release on GitHub and it will attach all the build files to that release, so that way the users can directly download it. But since we are talking about a private project,
Mm-hmm.
we can have a generic server. So you can just create a normal HTTP server that accepts certain requests that are required. So this will just, upon building the app, it will send the file to that server, or you can use S3. This is super simple. You just provide these keys and credentials in the like Electron Builder config, and it automatically uploads the build to your bucket, and then you can just serve the link to this download URL on your landing page or something.
Nice. Cool.
Yeah.
Thanks. 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 Okay. All right. So any words for someone? So maybe like an indie developer that wants to build their next great desktop Electron app. Any gotchas, anything to look out for? From your experience in working in an app like Sizzy, I know you've definitely seen a lot of gotcha
Yeah.
pitfalls with Electron, maybe even Node or Chromium, or just
Yeah.
your own unique use cases. So, what are your words?
Uh, yeah, like one thing I've seen a lot of developers say, like they worry too much about the performance of Electron,
Mm-hmm.
So Electron is basically starting Chrome process under the hood, and Chrome is very infamous for hogging up your RAM and stuff.
Yeah,
That's why people worry a lot. Like if I create an Electron app, it will not be performant, it will use up a lot of resources, it will be slow and stuff like that. But if you look at the case studies, like even VS Code is using Electron. VS Code is
yeah,
something which has to be very performant. Yeah, even Slack and Spotify, which have millions of users and millions of dollars in funding, they are still using Electron.
true.
So it's not like if you use Electron your performance will be terrible. It depends on your use case. If you are
Okay,
just uh, if big companies like these can manage to create an awesome product while having a decent performance, you can like your small app can manage it too. Like, and there are many ways to optimize your performance, but you probably won't hit that wall until very long, and even if you do hit it, it's very manageable. So don't worry about these. Just ship your product and get it out in the world. Otherwise you'll have to, if you keep worrying about these things, you'll be stuck there, or you'll have to rewrite your application in a number of languages. You'll have to write like Swift UI for Mac, and like Visual Basic for Windows and stuff like that. Instead of that, just focus on shipping and build your app.
Nice. Thank you. Thank you so much. So, if anyone want to reach out to you, like, okay, on Electron or anything, maybe React or whatever, where could they reach you on?
Yeah, you can reach me on Twitter. My Twitter handle is Praneet_RO, or you can email me if you don't use Twitter. My email ID is hey at the rate praneet.dev. So that's where you can reach me.
Nice, nice, definitely. So I'm going to link to the Twitter, of course, in the description.
Yeah,
So
yeah.
excellent chat with you, excellent time. I really learned a lot. Like I have actionable step I can use in something really quite real, which is guppy. So thank you. This has been awesome, and I'm glad we had the session.
Yeah, I'm glad to. Thank you for hosting me. This has been amazing.
Yeah, sure.